Good day, everyone. For today, we are going to learn about linear transformations. Don't you know that many of the geometric operations, such as translation, rotation, contraction, and dilation, are linear transformations? In fact, this concept on matrix operations are very useful in computer graphics and animation, to name few. Okay, so let us know what are the objectives for today. Introduction to linear transformations. At the end of the lesson, you should be able to find the image and pre-image of a function, show that a function is a linear transformation, and find a linear transformation. Images and pre-images of functions. In this section, we will learn about functions that map a vector space V into a vector space W. It's given by this notation. This type of function is denoted by T, which maps V into W. The standard function terminology is used for such functions. For instance, V is the domain of T and W is the codomain of T. If vector V is in V and vector W is in W, such that the transformation of V is equal to W, then W is the image of V under T. The set of all images of vectors in V is the range of T, and the set of all V in V such that T of V is equal to W is the pre-image of W. See below. So we can see here we have two vector spaces. We will call V as the domain and we will call W as the codomain. We see that the transformation of V is W under T. And we will call all images of the vectors in V to be the range of T. For any vector V whose components are V sub 1 and V sub 2 in R square, define T, which is a function that maps R square to R square by T of V sub 1, V sub 2, which is equivalent to V sub 1 minus V sub 2 as the first component and V sub 1 plus 2V sub 2 as the second component. A. Find the image of V whose components are negative 1 and 2. B. Find the image of V whose components are 0 and 0. And C. Find the pre-image of W whose components are negative 1 and 11. Now, how do we solve it? So, for V, which has the components negative 1 and 2, all we need to do is to apply the transformation. So, say the transform or the transformation of the vector negative 1, 2 is, so this one is equivalent to V sub 1 minus V sub 2. So since this is our V sub 1 and this is our V sub 2, then V sub 1, that's negative 1 minus 2, that will be equivalent to negative 3. And for the second component, we will have V sub 1 plus 2V sub 2. So that means we will have V sub 1 being negative 1 plus 2 times V sub 2, which is 2, negative 1 plus 2 times 2, that will be 4. So the answer is equivalent to 3. So this is how we find the transformation or the image of a vector. We simply substitute the vector according to the rule of the transformation. Letter B. If V has components 0 and 0, find the image of V under T. So again, we will have the transformation of the vector V being equal to, so again, we will have here V sub 1 minus V sub 2. And the second component being V sub 1 plus 2V sub 2. And it's clear that we will have 0 minus 0 is 0. And then we still have 0 plus 2 times 0 is still 0. For letter C, we're asked to find the pre-image of W whose components are -1 and 11. We know that the image of V, or the transformation of the vector V, is given by the following. First component is V sub 1 minus V sub 2, and second component is V sub 1 plus 2V sub 2. And since we're solving for this vector V, we know that the image of this vector is given by -1 and 11. So in order to find the components of the vector V being V sub 1 and V sub 2, all we have to do is to apply our vector equation. So we will have the first component, V sub 1 minus V sub 2, is equal to -1. And then we also have V sub 1 plus 2V sub 2 equivalent to 11. And all we have to do is simply solve the system of equation. And as we can see here, we can, that is as equation 1 and that is as equation 2. And if you say 1 minus 2, we'll be able to eliminate V sub 1 so that we will have a negative V sub 2 minus 2V sub 2 will be equivalent to a -3V sub 2, right? So, which is equivalent to, we have -1 minus 11, so that will be -12, and we can solve for V sub 2, which is simply 4. And then we can use this value now in equation 1 to find V sub 1, and V sub 1 is simply -1 plus V sub 2. So that will be -1 plus 4, then V sub 1 is equal to 2. So this system of equation has the unique solution where V sub 1 is equal to 3 and V sub 2 is equal to 4. So the pre-image of the vector -1 and 11 is the set in R square consisting of the single vector wherein the first component is 3 and the second component is 4.